Okay, excellent. So here we are going to solve our second example of rational inequalities. And what we want to do, it's already in this nice factored form, so why don't we just use that to start off. Here you can see that a value of -5 is going to make this 0. 0 times anything divided by anything is 0, so that's a critical point. Also a value of 3. Open circles because we don't have the line underneath. This is interesting because it looks like you might have to do something, but this is always positive, so we'll never create an asymptote or division by 0. And here you have an asymptote at the value of 2. Okay, algebraically, we could then look -10. So that would give us 20 minus 10 is positive. -10 would give you 3 minus -10, which is 13, positive. -10, this is definitely positive all the time. And here, -10 squared, anything squared will be positive there. Okay, so therefore, you are looking at a positive region. You are not interested because you want the graph in its negative region. Here, between -5 and 2, pick 0. That's a nice easy one. This is always positive, positive. 0 becomes positive, and this becomes negative. So your graph is negative, which you want. Between 2 and 3, let's take something like 2.5. 2.5 is going to give you -5, -15. Here, 2.5 will give you positive. Here, positive, positive, so your graph is negative. And something bigger than 3, say 10, again positive, positive. Here you're going to get negative, and here you're going to get negative. 3 minus 10, negative. Okay. Negative times a negative is positive. We're not interested in that region either. An interesting scenario because you have all answers between -5 and 3, but x cannot equal 2 because that would create division by 0. All right, again, there's your algebraic approach, the much easier approach if it's already factored. However, let's assume that we want to look at and solve it graphically. A little bit tricky, but what you definitely want to have a look at is here. Oh, it's not going to like that. Why don't I do this? Okay. You want to look at these points, and then over here you're not sure where, so you might want to zoom in here, and then you'll see that it goes above and then below, above the line there. And here you have an asymptote there. You can see the graph coming down, getting closer, and getting closer from there. Again, you get all those critical values by playing around with the window. Algebraically, analytically, we can see them from the factored form. But if you had something ugly, you'd need to play with the window a little bit. Okay, so we can find these values exactly by, again, making sure that we've put the graph with brackets around the whole entire top and around the entire denominator. We're graphing the left-hand side and 0 on the right-hand side. Okay? Then we want to find where those graphs meet over here. Enter, enter, enter. And we see -5. That's the value we found analytically as well. Then here there's something happening. And let's find that one there. So when we're looking for the intersect, we need to come all the way across, and up and down will toggle between the two different curves. Left and right goes along the way. First curve, second curve, enter. And you'll see 3, which we also saw is a point here. The tricky one to see is the asymptote. So you would really need to see, okay, where is it that it's getting closer to but never touching? One thing that you could have a look at is the table. Because if we look at the table, we can see that there's an error here. Whoops. There's an error at the value of 2. Okay, so there you can see the asymptote. The only thing you might need to play with when you do the table is the way that you're starting and how you're counting. Okay? Good. So that is example number 2.